Hello, students. Welcome. I want to welcome you, especially to our second lesson of curriculum-based task. We will be doing some more practice so as to be prepared for our national exam that we will be sitting in a matter of just a couple of weeks. So I hope you have been doing your own practice. I hope you have been doing your own practice so that you can be fully equipped. I intend to be here as often as I can, and I will be here tomorrow at the same time. Now, please go ahead and share the link with your friends and your classmates so that they can all benefit from this practice session that we're having. And as usual, I like to know which school you're tuning in from. So in the chat, please go ahead and type the school that you're tuning in from, and let's get started. Now, curriculum-based tasks, they're not strangers. it Curriculum-based tasks, it's not something very new. You have been doing these in class. In class, you have been doing these sort of items. It's not called a curriculum-based task, but it's basically questions, items that are being used to assess the concepts that you're learning in class. And that is exactly what the curriculum-based task is about. All right, so let's get right into our first question. All right, so this question says, which problem could the expression below help solve? Now look at this expression, a half divided by 8. And before we look at the different problems that are presented, can you explain to me what a half divided by 8 is really asking? Like, could you even give me an example of how we could really use this? A half divided by 8, what is that really saying? Go ahead and share in the chat so I can see what you understand from a half divided by 8. Welcome, Nicola. Welcome, Jalissa and Madison. Welcome, King. All right, so let's go ahead and think about this. All right, so Robloxian, welcome, says, what is half of 8? What is half of 8? Is that what it's really asking? All right, let me hear. So King says 8 divided by, is that 12 or a half? Welcome, Emily. All right. All right. So tell me, half divided by 8, what does that mean? What does that mean? So no, I'm not asking you the answer for this. I want us to talk about what half divided by 8 could mean. What does it mean? So I see one person saying we're asking what is half of 8, but what does it really mean? Okay, so Audrey says that a half split into 8 parts. Nicola says it's saying you have half of something and you need to share it into 8. All right. Jalisa says half of a whole divided by 8. All right. Those are wonderful explanations so far. Definitely. We have a half of something, a half of whatever, a whole, a half of liquid, a half of cake, a half of anything, a half of classroom, something. And we're dividing that half into 8 equal parts. So it's not about dividing your 8 in half. It's dividing your half into 8 equal parts. Now that we have established that, and you understand what that is really saying, let us look at the 4 problems that are given. The first one says, so we need to know, which of these 4 problems could be used or matches this expression. Okay, so A says, what is the total feed that 2 chickens eat if each chicken is given 1/8 kilogram of feed? Do you think that matches the expression given? What is the total feed that 2 chickens eat if each chicken is given 1/8 kilograms of feed? Do you think that matches this expression here? If it doesn't match it though, what is this question asking? If it's not matching this expression, what is the question asking? Because, okay, so King says no, it's not matching the expression. So what is the question asking? And Audrey is agreeing as well. What is the total feed that 2 chickens eat if each chicken is given 1/8 kilogram of feed? What is the question asking? Two chickens eat, the total amount that 2 chickens eat if each chicken is given 1/8 kilogram of feed. So we have established, yes, based on your responses, that it doesn't match. These two cannot go together. This problem could not be solved using this expression. All right, so Jalisa says here we're dividing 1/8 by 2. All right, so let me see what is the total feed that 2 chickens eat if each chicken is given 1/8 kilogram of feed. So if each chicken is given 1/8 kilogram of feed, all right, so Jalisa, you say 1/8 divided by 2. But it says each chicken is given 1/8 kilogram of feed. Yes, Audrey says how much 2 chickens will eat. All right, so what kind of expression could we use by this? Jalisa is saying 1/8 divided by 8. But let's look at it. It's saying we have 2 chicken and each of them gets 1/8 kilogram of feed. 2 chicken, each of them get 1/8 kilogram of feed. How do you think we could represent that? Because yes, we said that this expression would not work, but what would work? Very good, Audrey. 1/8 multiplied by 2, because we're multiplying 1/8 for 1 chicken, another 1/8, or we're adding rather 1/8 for 1 chicken and another 1/8 for the next chicken. So we could add 1/8 plus 1/8, or we multiply it by 2. Brilliant. Very good. That is what we'll be doing. Now let's look at the second problem at B. It says, how much milk will each child get if 8 children share half liter of milk equally? Let's look at that problem. Can this expression be used to solve this question? How much milk will each child get if 8 children share half liter of milk equally? Let's look at that problem. Can this expression be used to solve it? Let's think about it. How much milk will each child get if 8 children share half liter of milk equally? All right, so King says yes. Now, guys, what we can actually do is we can think about these in practical situations because they're practical problems. You can think about them in practical situations. So Jalissa is also agreeing, Audrey is agreeing, and they're saying, yes, this one will match this one. Let me see if it really will. How much milk will each child get if 8 children share half liter of milk equally? So we're sharing half liter of milk among 8 children. That means we're dividing half by 8. Wow. And that is brilliant because in our previous discussion, we did say that is what half divided by 8 means. So we are on the right track. But let's see C. Let's see if C or D or and D will match it. And B really didn't make any sense. Like sometimes we go to a next question, a next option that makes a lot more sense. But let's look at it. C says, if each cake requires half liter of milk, how much milk will be used to make 8 cakes? If each cake requires half liter of milk, how much milk will be used to make 8 cakes? How could we, or what expression could we use for that one? Could we use half divided by 8, or another expression will work instead? If each cake requires half liter of milk, how much milk will be used to make 8 cakes? All right, so I see where Nicola says half times 8. Audrey is agreeing, and I agree too, because if one cake is half liter, 2 cakes is 2 times a half, or half plus half. 3 cakes is 3 times a half, or half plus half plus half. And so 8 cake is 8 times a half, or you're adding a half 8 times. Very good. Very good, guys. So I see where we are certainly on point. Let's look at D. 16 children are divided into 2 equal groups. Let's take it part by part and think about it like a practical situation. If each child receives 8 pieces of candy, how many pieces of candy are required for each group of children? So 16 children are divided into 2 equal groups. If each child receives 8 pieces of candy, how many pieces of candy are required for each group of children? All right, so go ahead and tell me what expression will work here. 16 children are divided into 2 equal groups. Each child receives 8 pieces of candy. How many pieces of candy are required for each group of children? Let me see what you think here. Now, of course, you would have seen the correct answer. And we have established, yes, that that is definitely a problem matching the expression. But let's look at D here. All right, so I see persons are giving me answers, but I don't want us to go to the answer. I want you to tell me what expression would match this problem. What expression would match this problem? So yes, you're coming up with answers, but how did you come up with your answer? So tell me what expression would match it. All right, so I see Jalissa saying 2 multiplied by 8. Are you sure? I see Nicola saying 16 divided by 2 equal 8, and 8 eighths equal 1. I see Audrey saying 16 divided by 2. Let's look at this problem. So 16 children are divided into 2 equal groups. Each child receives 8 pieces of candy. How many pieces of candy are required for each group of children? Now, first we need to know how many candies, will the children have together. So if each child gets 8 pieces of candy, how many candy would there be in all now? So you have 16 children, and each of those 16 children will get 8 pieces of candy. So let's think about that. What expression do we need there? What expression will we be using there? So even though the numbers 16 and 2 came first, let's think about how all these numbers relate and how are we going to use all these numbers. 16 children are divided into 2 equal groups, but it's still 16 children, right? Yes, it's still 16 children. If each child receives 8 pieces of candy, how many pieces of candy are required for each group of children? First, we need to know how many candies how many candles will there be in all. So we need to know if 16 children gets 8 pieces of candy each, how many pieces of candy will there be in all? And then we know that, okay, that amount of candy will be there in all, but we want to see then how much will be in each group. So if you look at it, we first have to decide how many 16 children receiving 8 pieces of candy each would be how many pieces of candy in total? Go ahead, type your response in the chat. Go ahead and type your response in the chat. How many pieces of candy will there be in all? So remember now, we have to try to read these problems, think about it in a logical way, think about it in a practical way. Because even if we say, okay, 16 divided by 2 is equal to 8, what are we going to do now with each child getting 8 pieces of candy each? Tell me. Where would that come in now? How would that, really come in? Because if we have 8 right there, 16 children, and we divide the group of children into 2, so we have 8 in each group, what will we do next? Because I'm not saying that we cannot solve it like that, but we can think about it in a logical way. And because I'm not seeing any complete, statement here, or any expression or even equation here to answer that. But what I would do, because it's simpler for me, something else could be simpler for you, is to see how many pieces of candy will there be in all for the 16 children. And so I would multiply the 16 children by 8 pieces of candy each. And I'm seeing where King and Audrey are saying 128 pieces of candy in all. And they agree. So now that we know that, very good, Audrey's ahead of us. Now that we know that, we now need to divide that into 2 groups. Divide the number of candies, because we know that each of the children will have these candies. We now need to divide that in 2 groups, 2 equal groups, so we know that how many pieces of candy will be required for each group of children. And so Audrey went ahead and she did 128 divided by 2, and she got 64. Very good. All right. And so we know that that will not match the expression that we have, but instead B matches it, that says how much milk will each child get if 8 children share half liter of milk equally. Very good. I'm enjoying our discourse so far. Very good. Let's move on to the next question. Now, the next question says, Sammy drew a number line on his paper. Now, this is the number line that he drew. Jack drew a new point, 45% of the distance from point E to point J. Between which 2 letters does the new point lie? Now, let me just, I want to hear from you first, of course, but let me just be prepared to now show where 45% of the distance between point E and point J might be or could be. But I want us to have a discussion. If Jack drew a new point at 45% of the distance from point E to point J, where would that 45% new point be? Go ahead and share. Go ahead and share in the chat, as well as explain to us how you came about that, new point. So I want to hear from you guys. And you have been doing very good so far. Now I want to hear how you would solve this. Between which 2 letters does the new point lie? How do you know? And of course, in the curriculum-based task, you don't need to write how you know, but bear in mind that you will not see these exact questions in that exam. And so if you understand how to answer some of these questions, then you will be able to transfer that learning to a question you have never seen before. So we need to talk about it. Where did Jack drew that 45% new point? The new point, where did he put it? So I see you guys giving some answers. You're saying A, G, and H. I'm not saying you're correct. I'm not saying you're wrong. But we have to talk about it first. So let's talk about it. So we have point E, F, G, H, I, and J. How did you get A to be your answer, Nia? And King, why did you say G, H? Nia, why did you say F and G? Tell me. I want you guys to tell me, how did you come up with these responses? Emily, why did you say F and G? No, you guys are giving me answers. No problem. But you know I want to see some justification. How did you come up with those responses? How did you come up with your answer? All right. All right. So let's look at this. We have a point E, F, G, H, I, and J. We have 6 points here. Now, 45%, where is that? If we are able to find 50%, which is halfway, then we're able to, guess and judge and, estimate that this is 45%. So let's go ahead and let us point out where 50% will be. So I'm looking halfway here. 1, 2, 1, 2 at each side. And then I will split this middle part in half. Let me just go ahead and do that just like this. All right, so this is not, measured or drawn to scale. And so, my intention is to go halfway between G and H. Now, we're talking about 45%, but we don't know where 45% is. We know though that 45% is between, well, it's definitely before H. It cannot be beyond H. So we know it has to be before H because 45% is less than 50%. Now let us look at these different spaces between these letters to see if we can come up with something, a little more specific. Now, if you look from here, we can't just say, okay, so 45% is somewhere here. We don't know. So let us go ahead and think about this. So half of this, like from E to right where this red line is, represents 50%. And so does from the red line to J. Now, let us try to divide this 50% into 10 equal parts, like 10%. So, okay, let me just pause here because I see persons explaining some stuff here in the chat. So Emily says, she says F and G because half of the number line lie between G and H and 45% is less than 50. All right, very good point, Emily. Nicola says there are 6 points in all. 50% would be 6 divided by 2, which is 3. The third letter is G, which is a half. 45% is less than a half. So it would be F and G. All right, so that's what Nicola says. Nia says F and G. Because between G and H is the halfway point, and 45% is before half, so between F and G would be 45%. But look here, guys, couldn't write here, so which is less than 50 also be 45%. Think about it. Couldn't it be here as well? Remember, between this G point and this halfway mark that we have with the red line, this is less than 52. Couldn't it be here? So those are very good points that you guys would have shared, and I appreciate them. So I was saying that what we could do is we could divide this 50% into some 10-10. So let me go ahead and try to do that. All right, so this is half of between 2 points, and half of these 2 points will give me 1, 2, 3 equal parts. Let me go ahead and put some lines there to point that out. And half between here again will give me 2. Let me see if these can be 10-10. So 10, 20, 30, 40, 50. Wow. Yes, so that can actually be 50%. So it means that this is 10%, 20%, 30%, 40%, and halfway between the G and this halfway red mark that we have for 50%. Let me just get a different color right here. Halfway would be 45%. See if you're following me, guys. Let me divide all of this so we have equal points so we can count based on that. Let me count so we have equal points, not drawn to scale. So let's go. So let us count this together. Let's say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So 45 would be right here. And if 45 is right here, this would be between G and H. I hope you guys would have seen that. I hope you guys would have seen that and you understand my explanation. All right. And so the correct answer would be between G and H. All right. So now remember that you can always go back and you can replay this video, pause at the points that you need, you need to think about a little deeper if I am going too fast. All right. So this is how we could come up with our answer right here. I know, yes, it was easy enough to say it's between F and G, but guys, see where it's between G and H, sometimes we have to do a little marking up. All right, sometimes we have to draw some lines on our paper and work it out and not just say, oh, it's between F and G. All right, this is one extra point, so you would want to get it. All right, guys, so let us move on to our next question. Great, guys. So the next question says 1 serving of Ace's crackers has 150 calories and a mass of 30 grams. How many calories are in 6 grams of the crackers? Now, of course, I want you guys to work this out on your own and give me a justification for your answer. 1 serving of Ace's crackers has 150 calories. 150 calories. And that same 1 serving has a mass of 30 grams. All right, so yes, KK, you have done this today in extra lessons, but hear what? If you don't understand how to explain, or if you're unable to explain how you come up with your answer, then I mean, it may be challenging to do another question like this. So the aim is that you are able to justify your answer. You don't need to do that on your paper, your exam paper, but for sure you will not be seeing this exact question coming back on your exam paper. So I want you to explain how you got your answer. How did you get 30? How did you solve it to get 30? Explain why did you solve it the way you did to get 30? Because it's very important to know how to solve the question. So when you see a similar question to it, you're able to transfer that learning to solve it. So tell me, guys. Okay, Emily is also saying 30 calories. Why did you say 30 calories? Why is your answer 30? How did you get 30 for your answer? So go ahead and share with me, how did you get 30 for your answer? All right. So if it says 1 serving of Ace's crackers has 150 calories and a mass of 30 grams, how many calories are in 6 grams of the crackers? I want to see how you came up with your answer. How did you get 30? I see you are putting 30 for your answer, but how did you come up with 30? How did you work it out? Can you explain it to me so I can see how I can try to work it out as well? That is where I want us to go. How is 30 the correct answer? I mean, the answer could be 5, could be 10, and it also could be 25. Because if I throw around these numbers, and I use some operation on them, most likely I can come up with one of these answers. So Roger and William says 30 calories divided by 6. So 30 calories divided by 6. All right, so I don't think you're finished, Roger. So you have divided 30 calories by 6. I wonder why we're doing that. Why are we dividing 30 calories by 6? Why? So I want you guys to explain. Rajan, you can go ahead and give me a further explanation on what you're saying so far. We're dividing 30 calories by 6. All right, so Audrey is saying 30 multiplied by 5 is equal to 150. 6 times 5 is equal to 30. That's a very good takeaway from this question, Audrey. How did you come up with those numbers? I can see 36 and 150 in the question, but how did you come up with 30 and 5? Emily says that 30 grams multiplied by 5 is 150. So the same rule is going to apply to the other number of grams. KK says, how I got my answer is I divided 150 by and 30 by 5, then multiply by 6, which equals to 30. All right, Nicola says the ratio is 1 to 150 to 30. Now it is 6 grams. The new ratio is, all right, blank, blank, 6. You divide 30 by 5, then you would do that for the rest. 150 divided by 5 is 30, so 30 to 6. All right. Let's see. Let us go ahead and let us start exploring this question. Now, it says here it is given that 150 calories and a mass of 30 grams is in one serving of cracker. So yes, we can say 150 calories to 30 grams. Cool. Yes, that is really good for you to recognize. How many calories are in 6 grams of crackers? Now we have 30 grams of crackers, but it is only asking us for what fraction of 30 grams. 6 grams of crackers is 1/5. Let me go ahead and annotate here. 6 grams of crackers is 1/5 of 30 grams of crackers, right? So in order to get this 6 grams, we could find 1/5 of 30. So the relationship between 6 and 30 is 1/5 of 30. Now, someone had mentioned we just need to do the same for everything, and that works. And yes, you are so right. So I want us to think about it. Someone mentioned ratio. That is very good. Proportion. All of those things are coming into play with this question. So here, okay, so you're asking if your explanation is correct. So I'm explaining here for you to see if your explanation is correct. You're saying that you divide 150 and 30 and that is equal to 5, then you multiply by 6. Now you got those numbers 30 and 5, but how did you get it? So I want us to talk about how we got those numbers. All right, so here we have we were told that the mass of one serving is 30 grams, and the question is asking us about 6 grams. What's the relationship between the 6 grams and the 30 grams? And if you realize here, you realize that 1/5 of 30, we could say 30 divided by 6, which would give us the 1/5 of 30, of course. So 1/5 of 30, that is where we got our 6 grams from. So we came up with our 6 grams because we found 1/5 of 30. So here we can definitely divide 5 into itself goes 1, 5 into 30 goes 6, 6 times 1, 6, and 1 times 1, 1. So 6. But now we know that 1/5 of 30 is 6. It's quite easy now for us to say, okay, we need to now find 1/5 of 150. Tell me if you're following me now. Because we came up with this 6 grams here, we have to use that same way to come up with, whatever the answer is for using the 150. So 1/5 of 150 would give us what? And of course, there are many different ways to think about this question. There are many different ways to solve it. So go ahead. Can we now find 1/5 of 150? All right, so Rochen responded to say 30. Let's see. So 5 into itself goes 1 time. 5 into 150, so let me see. 5 into 15 goes 3. And 5 into 0 goes 0. So 30 times 1 is 30, and 1 times 1 is 1. So yes, it asks how many calories are in 6 grams. 30 calories are in 6 grams, because we just need to do some fraction, find some equivalence between the 30 grams and the 150 grams. And this is one way to solve this problem. So yes, we have come up with our 30 calories, and I know that a few of you already said that, but I just wanted to see an explanation. All right. All right, great. So here we are at this question. Let us move to another question. All right. So this question says, to clean a tank, 3/4 liter of disinfectant is needed for every 4 liters of water. How many liters of disinfectant are needed for 40 liters of water? So to clean a tank, we need 3/4 liter of disinfectant, because we have to think about this problem as a real problem. Yes, we can. We can definitely do that, KK. So we can use whatever procedure works for us, whatever way we can answer the question that makes sense, that is logical, we can use it. Once we can use that to answer many other questions. Now, yes, some of you would have seen these questions, but I am more looking for the justification. Because if ministry set the paper and give you one question like this, not the same question, but one like this, will you be able to answer it? So let's think about this as a literal, a practical situation. So we're going to clean a tank, and we need 3/4 liter of disinfectant to clean every 4 liters of water. How many liters of disinfectant are needed for 40 liters of water? How will we solve this? How can we come up with our answer? What do we need to think about? Those are some questions I want to ask. Now, we have just gotten to the question, and I see persons typing answers in the chat. I see 7.5, I see A. But given that you're saying those are your answers, how did you come up with those answers? How did you work it out? What relationship is there between these numbers? How did you come up with your answer? So I'm seeing some answers in the chat, and as I'm saying, I'm not saying whether they're correct or not, but we have to be able to explain how we come up with our answers. Otherwise, they don't mean much to me. So here I'm seeing Nicola says we should use ratio. How, Nicola? KK says, see how much time 4 can go into 40, which is 10. Then you multiply by 3/4. All right. Audrey says how many 4 are in 40. All right. You guys are definitely onto something good right there. So let's look at it. So it says 3/4 liters of disinfectant is needed for every 4 liters of water. So we have to see how many 4 liters of water we can get from 40 liters. All right, so yes, guys, we are definitely on the same page. And that is what I love because I want you guys to tell me how I can solve it. So here we're going to divide the 40 by 4. So we're going to divide 40 by 4 to see how many 4 liters we can get. So we divide 40 by 4. 4 into itself goes 1 time. 4 into 40 goes 10 times. I see your answers coming in already. So this is 10. 40 divided by 4 is 10. So we're looking at it now, and it says we can get 10 4 liters of water. If 1 4 liter of water takes 3/4 liter of disinfectant, how many disinfectant will we need for, 2 4 liters of water and 3 4 liters of water and so on? How would we solve that? So we can say 1 multiplied by 3/4, that is for 1 4 liter of water. For 2 4 liter of water, that is 2 multiplied by 3/4 liter of disinfectant. And I'm following what you guys are doing. Really good, by the way. So we have 10 sets of 4 liters of water. And in order to know how many liters of disinfectant we need for the 40 liters of water, yes, as you guys said, we'll need to multiply. So we're going to multiply our 10 liters of water by 3/4. I hope we're following each other so far. So let us write that. And surely we can just put this over 1, right? All right. All right, so let's go. So let's see how this will work for us. All right, let's do some reduction. 2 into 4, 2. 2 into 10, 5. Okay, so we're now going to multiply across. So we're going to say 5 times 3. That is 15. 5 times 3 is 15, and 2 times 1, that is 2. So from this here, we are now at 15 halves, or 15 divided by 2. Let me know, guys, if you're following me so far. So after this, we have 10 multiplied by 3/4. We have now ended up with 10 halves. So now that we have 10 halves, or 10 divided by 2, what are we now expecting to get? 2 into 15 goes 7 times, and 1 remainder, which we write it over 2. And that is 7.5. All right, very good. I see we're all on the same page. And so, of course, initially you were correct when you said that the answer is 7.5. But we need to have our justification, our calculation, and people need to know how to solve this. All right, so thank you guys for sharing in the chat how you would solve a question like this. And I'm really proud of you because some of you, I've had you on this channel for months and I can see the growth in some of you students. I'm really proud. Now let us look at our final question for today. So this question says, the table shows the number of kilometers 4 friends travel to get to school. Who travels the greatest distance to school? And I want you guys to talk about this here in the chat. I want you to talk how we can solve this in the chat. I want a very fruitful discourse. I want persons responding to persons in the chat. Let us look at this. So the table shows the number of kilometers these 4 friends, Andy, Helen, Michelle, and Troy, travel to get to school. Andy travels 1 3/8 kilometers. Helen travels 1 2/3 kilometers. Michelle travels 1 5/9 kilometers. Troy travels 1 4/9 kilometers. So basically, you realize that each friend travels 1 kilometer and some, right? 1 kilometer and some. So nobody travels in more than 2 kilometers. They travel 1 kilometer and a fraction of another kilometer. So let us look at what is happening here. Who travels the greatest distance to school? How do you know? So I see answers coming in. I see C, which is Michelle. I see Audrey saying Helen. How do you know? Did you draw up a model in your book to solve this? How did you come up with your answer? Terika Short says Michelle. How did you work this out? Can you just look at it and know? Can you just look at it and know? Or you may have to do some calculation. So KK says we're going to have to find the LCM of the denominators, which is 72. All right, now this is one way to solve it, and we can explore that way. So let us go ahead and explore that way. So she says that we can find the LCM. So I'm supposing you mean the LCM of all these denominators. So we're going to find the LCM of the denominator. She says it is 72. Now, go ahead, guys, and do your calculation and let me know if you agree that the LCM will be 72. Now, remember now that LCM has to do with that common number, the common multiple, that if we're to divide each of these denominators in that number, the lowest one, by the way, there will not be a remainder. So you can go ahead and tell me, do you agree with KK that the LCM is 72? Are we agreeing that the LCM is 72? All right, so Nicola says, first let me read what Emily says. Emily says, if you compare the fractions, you will see Michelle is the greatest, as the greatest fraction. All right. Nicola says, whichever fraction is the closest to the denominator would be more. Okay. All right. So, and KJDW says, Helen, because the less the denominator is, the smaller the denominator, it is more. All right. And Rogen says to use benchmark. All right. So, yes, we can use benchmarks. So I see persons are sharing how to solve this. But first, KK had said, let us use 72 as our denominator. So yes, what is common is that each of them has a one whole. So let us just compare the fractional parts. Let's compare the fractional parts. And of course, we can also convert this into an improper fraction. But we can also just compare the fractional parts because all of them, all of the whole is the same. So let us go ahead and we're going to work with that LCM as was shared. We could try. So I'm going to write all the fractions here. All the fractional parts here. And we're going to try to use that LCM that you shared. All right. All right, so we didn't even have to compare 4 9s because we have 5 9s already, which is great. So, you know, it would really show. So let us go ahead now and do these with the denominator of 72. I'm just going to draw a line here and I'm going to write my 72 here. We commonly do this, no problem. And then we're going to do our division. So 8 into 72 goes how much time now? Go ahead, and I want you guys to share in the chat with me. I want you guys to help me to work this out. 8 into 72 goes how many times? Go ahead and share that in the chat. When you divide 72 by 8, what do you get? Because we want to see what is the greatest distance? Who traveled the greatest distance? So 72 divided by 8 goes, thank you Roblox, 9 times. All right. You can use whichever one you're comfortable with, Nicola. All right. So 9 times, and 9 times 3 is what? 9 times 3 is 27. All right. Now 3 into 72 goes how many times now? 3 into 72 goes how many times? All right, so that goes 24 times. So let's go ahead and multiply our numerator by this 24. 2 times 24, that would be 48. All right, very good guys so far. And then let us go to our next denominator, 9. 9 into 72 goes, how many equal groups of 9 can we get out of 72? All right, very good. Yes, we will get 8. So we multiply our numerator by that 8. So 5 times 8 is 5 multiplied by 8. All right, that would be 40. And 9 into 72 is still 8. So let's go ahead and multiply that by 8. 8 times 4. All right, so 8 times 4 is 32. And this, of course, is one way of figuring out our answer. So now we need to look to see which of these have the greatest fraction. We have 27 over 72 for 3/8. We have 48 over 72 for 2/3. 5/9 is 40 over 72. And 4/9 is 32 over 72. So if we look at it, we realize that 48 is the greatest. And 48 over 72 is equivalent to 2/3, isn't it? Yes, it's equivalent to 2/3. And so that would mean 1 and 2/3 Helen would therefore travel the greatest distance to school. But as I said, this is one way of figuring this out. So if you had said Helen, trust me, you are correct. Very good job. Now, this is another way we could look at it. So we could look at it as this. And of course, since they all have the same whole, which is 1, we can just go ahead and compare the fractional parts. So with what we have here, or what I am displaying here, what I did is that I created 4 wholes, which are the same sizes, and then I represented each fractional part in the whole, and then we're able to compare it. And as you can see, 3/8 is right here, 2/3 is here, 5/9 and 4/9, and you would see that 2/3 is the greatest portion. And so it would simply mean then that Helen, which travels 1 2/3 kilometers to school, travels the greatest distance to school. So all of your explanations, guys, your explanations, the different ways you say that we can solve it, correct. Very good job. So we can solve these questions in different ways. It doesn't have to be one way. Sometimes it's not even 2 ways. All right, so you can definitely go ahead and use your own strategy once it makes sense to solve these problems. Now, this is the end of our session today, and I totally had a lot of fun discussing with you guys as we go through these problems. Now, tomorrow I want to meet here at the same time with you so we can explore a couple more items. And I want to also encourage you to keep practicing. I want you to keep practicing because coming here and what you're doing in class will not be enough. You need to practice in your own time. Try your best sometimes to find some items that will match what you are doing in class. So I want to wish you a very good evening, and I will see you tomorrow at 4 p.m. Bye bye.